Hi friends, and welcome to this session on sets and Venn diagram. This is indeed a very important topic as far as our CSAT exam is concerned. Even this is important for our exams like Bank PO and all other exams. So just pay immense attention on this topic. This is also important because this is slightly complicated one, right? There would be multiple ways of solving the questions in this topic, and there is a lot of theory if you look at any book. But as far as our exam purpose is concerned, we are not bothered about theory. We do not require definitions as such. What is a complement of set, what is a negative of set, what is addition of the sets. We don't require all this. What we require is an approach to solve the questions which we would be focusing in this session, right? But just to put things in perspective, let's start with definition of a set. So definition of a set is collection of well-defined objects. So collection of well-defined objects can be anything. For example, it can be the number of the students in your class, right? That can be a well-defined subject, or students in your school, right? Or the entire population of the world, entire population of India. So this is well-defined set. There can be another well-defined set, for example, set of real numbers, 1, 2, root 3, root 2 and all that stuff would come in this. There would be a set of alphabets, A, B, C, D up to Z. So a set is normally denoted by curly brackets and all the elements within that curly brackets, right? So for example, this is a set of real numbers, this is set of an alphabet. So set can be anything, right? It has to be well defined. So when we say set of population of world, right? So this is one set. We say set of population of India. This is another set. But you would see that population of India would be part of population of world, right? So we say that population of world is a superset and population of India is a subset, right? The other way of defining a set is, let's say a set A is equal to X, where, so a straight line, a colon, X belongs to integers and X lies between 0 and 2. Or we can put it any condition. So the bare minimum conditions is X belong to integer, so it would have all the integers, which is -1, -2, 0 and all that stuff. If we put a condition here, which earlier it was there, so X lies between 3 and 5, -3 and 5, so there would be all those integers which are between -3 and 5, which is -2, -1, 0, 1, 2, 3, 4. All those would be in this set A, right? So you see that set which was X belonging to integer has infinite number of elements, and this set has finite number of elements. So set can be anything. It can have infinite number of elements, or it can have finite elements, right? So let's go to what questions look like in our exam, right? So question would look like, typically talk about a simple set, right? For example, set of students in a class. So when we talk about such sets, set of students in a class doing certain kind of activities, so we define this by a rectangular box. So these are all the students in a class. Then the question, for example, the statements here says that there are students who play football, right? So out of all those students, there are few who play football. So this is it. Let's stick to this statement. So all those people who are within this circle, right? So the area within this are all those people who play football, which means all those people who are outside this do not play football. So if there are, let's say, 100 students in a class, so this rectangle we are actually bothered about number of elements in a set, right? We are not bothered about actually individual elements, but the number of elements. If you look at previous year question papers, you would see all the questions would talk about the number of elements and all that stuff. They would never talk about individual elements, right? So number of elements or number of students who play football would be this number, right? If total number of students are 50 and students playing football are again 40, right? Let's say this, in this circle there are 40. How many are left? What is left is 60. So we can say that 60 students do not play football, right? So this is those students who play football. Now we can complicate the things further as well, which is we can define those students who play cricket as well. So there are two possibilities. There are so number of students who play cricket can be something like this. So you would see that in this case there are no students who play both the sports, right? So number of people who are playing football are different. Number of people who are playing so all those who play football do not play cricket, right? And vice versa. So there are no overlapping between these two elements, right? So if total number of students is 100 again, right? Number of students who play football is 40. Number of students who play cricket is 30. Then how many of them do not play any of the two games is 40 plus 30, which is 70. 100 minus 70, so 30 would be in this outward range who play none of the two games, right? So they would be 30. Now there can be another case in which they overlap, right? So something like this happens, they overlap. Now what is happening? There are now 4 cases, right? Let's say there are people in this set, this one, right? Then there are people who are here, let me darken it, who are here in this region, right? So this region there are, and finally there are people who are outside this region, which can be shown by, let's say, this one, and finally which is outside these two sets, which is this whole region, so these are 4 regions, right? Let's number them so that we can talk about them easily. Let's call them A, B, C, D, right? So let the number of elements in this is A, in this is B, this is C, and this is D, right? Now you would see that the total population, total number of students in class would be A plus B plus C plus D, right? Number of students playing football, will be A plus B. So A plus B, it is number of students playing cricket would be how much? It would be B plus C, right? Then number of students playing both football and cricket, so both football and cricket. So pay attention to word and, right? And is important. It would be B, right? Then finally it would be number of students playing either of football, and here the word would be or cricket. That would be how much? So those students who play either of the two games would be how much? It would be A plus B plus C, right? Can you see it from the diagram? And finally number of students who play none. Who play neither of A and B would be how much? D, right? So this is the characteristic of this population or this set, right? Now let me introduce you with terms of set, right? So when we say number of students who play both the games A and B, we are talking about, so if this whole set, the red circle one, is A, let's say this whole set is A, this whole set is B. So number of elements in A would be how much? So number of elements in A is written as n of A. They are A plus B. Number of elements in B would be how much? B plus C. Now this is what? This is number of elements in what we define as A intersection B, right? So there is a term called intersection, which means those elements which are common in both A and B. So it would be denoted by inverted U, and it is written as A intersection B, right? So this is A intersection B. Now the next term is number of students playing either of football or cricket, which means either or, right? Either or, which means either football or cricket or both. This we define as union, number of elements in A union B. Union is defined by inverted U, the simple U. This would be A union B, right? So this is how we define union and intersection, which are most important definitions as far as our set theory is concerned, right? We can solve questions even without knowing the definitions of intersection and union, because CSAT or Bank PO would not ask you some definitions of union or intersection. There can be other state exams, for example UPPSC, which might ask you questions based on these definitions, right? So this is, as of now, what we have learned, right? So what is the total population? If we say number of so if we have to define number of elements in A union B, right? A union B, how many elements does it has? It would be simple. We know that it is A plus B plus C. How do we represent that in terms of n of A and n of B? It would be n of A plus n of B, right? N of B. Now when we are adding n of A plus n of B, which means students who are playing football or cricket, we are adding B twice, so we have to subtract one B, which is number of elements of A intersection B, right? So this is a very popular formula or definition which you would find in almost all the books. We don't require that, it's just for your information. So this is A intersection B, right? So the easiest approach to solve the questions is just draw the diagram, the Venn diagram, and just name a number the elements, right? So this is what is basic nomenclature of a set question, basically, right? Or a Venn diagram question, basically, right? So we can also further say that number of people who play only one game, which means we are talking about what? We are talking about A plus C. We are not talking about here B, because those B are all those people who play both the games, right? So it's A plus C, right? This is also important. Lots of questions would ask you something like this. So this is about 2 sets. We can extend the same theory to 3 sets as well, or 3 particular activities or groups as well, right? But let's firstly stick to these 2 sets theory only and solve few questions which were asked in CSAT. So this question says, in a city 9,000 houses subscribe to channel A, 12,000 to channel B. If 4,000 subscribe to both, how many of the households subscribe to none if the total population is 20,000, right? So total population shown by a outside rectangle. This is channel A. Let's do a channel B as well. This is channel B. right? So since they are intersecting, there are few people who subscribe to both, right? And then it says the total population is 20k. Let's put 20 here. Subscribing to A is 9k, so 9 here. Subscribing to B is 12k, 12 here. Subscribing to both is 4k, so 4 would be here, right? So this is our B, as our previous example was. This is our B. So what would be A? This would be 5, and this would be how much? 8, right? So A plus B was 9. We were given 9,000. B plus C was 12, so C was 8. Now A plus B plus C is how much? It would be 12 plus 5, 17. So rest of the people are 3, right? As simple as that. So how many people subscribe to neither of these channels? They would be 3,000 people. This was a CSAT question, and I hope that you can now easily solve it using Venn diagram technique. You don't need any other technique to solve this question. Now this question came in CSAT 2014. I'll give you 2 minutes, try and solve it, and then we'll do it together. So 2 minutes have not passed, but I think the question was easy and you must have solved it. Now in this question it is assumed, right? In the question itself you have to check for the question whether it is assuming certain things or not. So it is assuming that out these 50 students speak either any one of the two languages. So there is no student who speak none of these two languages, which means if this is those who speak English and this is those who speak Hindi, right? And we name them as A, B and C. This is English, let's say, and this is Hindi. What is given is A plus B plus C is 50, right? Then it's also given 10 students can speak both the languages, which means this is 10. If students who can speak English is 21, so English is 21, which means we can find A would be what? A would be 11, right? Because 11 plus 10 would make 21, and A plus B plus C has to be 50, so this has to be what? 29. Now you can solve any question based on this, right? You don't require to go further, draw the diagram and save any and solve any of the questions. So if you understand the basic concept, you don't need to know the definitions of union, intersection and all this stuff to solve these kind of questions, which are basically constituting the questions which appear in CSAT or bank view kind of stuff, right? The next question is an interesting one. I'll recommend it to you, and I'll give you around 2 minutes to solve this, then we'll do it together. So in an examination, 70% students got pass marks in paper 1, 60 in paper 2, 15% fail in both the papers, and 270 passed in both the papers. How many students are there, right? So this is slightly complicated because it has involved a concept now, percentages and numbers as well. So try and solve it, then we'll see how do we do it together. फिर दवांगे तसल्लियां जवाब नहीं. Let's do it. This seems to be slightly complex than the previous one, right? So there is a class. Let's say this is a class. Now he's talking about two things. One, those who passed in papers and those who failed. So we know that there is a universal set. So the bigger one is called a universal set, and the smaller one is called a subset of that universal set, right? So let's see, the red block says those who pass in exam 1, the blue block says those who pass in block 2, right? So 15% fail in both, which means what? Which means 15% lies here, they are passing in none. 15% fail in both, which means 85% pass in what? Pass in both the exam or either of the exam, right? So 15% fail in both the papers. This implies what? This implies 100 minus 15%, which is equal to 85%. So let me remove this percentage, which is equal to 85%. These 85% people pass in either of paper 1 or 2. Just be cognizant of either term, right? Either of paper 1 and 2, right? 15% fail in both means that these 15% students neither pass in paper 1 nor pass in paper 2, right? So rest of the 85% people either pass in paper 1 or in paper 2, but it does not imply that they pass in both. So it might be a case that they pass in both, but it is not an implied case. The implication is that 85% pass in either 1 or 2, right? Which means if this is a set A, this is set B, which means A union B is 85, right? So number of elements of A union B is 85. We know the number of elements in A is how many? 70. In B is how much? 60. And we can find what? Number of elements in A intersection B, right? So A intersection B. Or to make things easy, let's name these A, B and C, right? So from here A intersection B would come, A intersection B is what? It's B only, right? So B would come out to be how much? B would be equal to, just subtract it, 130 minus 85, it comes out to be 45, right? So B is 45. Even if you don't want to use this stuff, you can simply write A plus B plus C is equal to 85, right? A plus B is equal to 70, which implies C is equal to how much? C is equal to 15. Similarly, B plus C is equal to 60, which implies A is equal to how much? 25, right? And you can find B is equal to 45 from this as well. Now B is 45, and for these 45% people pass in both, right? And we are given that 45% who pass in both is equal to 270 in number, right? So if total students are T, 45% of T is 270, which means T is equal to 270 divided by 45%, which is nothing but 600 students, right? I hope that you would be able to solve this percentage form. We have already discussed the chapter on percentage. So T would be 600, right? So slightly complicated as you have seen from the previous one, but still doable, not very tough, right? So this is how we deal with those sets who has 2 elements. Now let's talk about those sets which have 3 elements. Things are almost same, just that they become bit complicated. So let's take a universal set. So this is a universal set. There would be 3 elements. Let's take one element. Let's assume that there are intersections, right? So this is element number 1, this is element number 2, and finally we'll do the element number 3 as well, right? So this is element number 3. So this is element number 3. Now if you see, the areas or the division of areas are many. So first and foremost area is this one. Let's do it later. The one is A, B, C, then there is D, E and F, and finally there is G and then H, right? So there are how many? 8 things, 8 elements in a set consists in 3 set theory, right? So what are these? Let's name these sets as A, B and C. Without going into unions and intersections, let's see what are these elements, right? So first of all, what is A? Small a. Small a is those elements, those numbers who do A only, right? A only. What is B? Similarly, those who do B only, right? That's B. And finally, what is C? Those who do C only. Right? These are A, B, C. So, for example, if these are 3 activities, cricket, football and tennis, so there are these A people only play cricket, right? Or these A people only play A. These B people only play B, and these C people only play C. Now what is E? E are those people who play or who do A and B only, A and B only, and not C, right? Similarly, F is those who do B and C only and not A, right? And D is those who do A and C only and not B. And finally, what is G? This means D plus E plus F would be what? D plus E plus F would be all those people who do 2 activities only, out of 3 who do 2 activities, right? Would be D plus E plus F. G would be all those people who do all the 3 activities. H is all those people who do none of the activities, right? Then there is another thing which is D plus E plus F plus G. These are what? These are those people who do at least 2 activities, right? Those people who do at least 2 activities are D plus E plus F plus G, right? you can also put them in intersection or union form if you want, but I don't want to complicate the stuff for you, so I'm not putting it. And then who are those people, what are those people who do A and B? Who do A and B? A and B, which means they do A as well as B. Who are those people? They would be E plus G, right? Those people who do A and C, A and C, they would be D plus G. And finally B and C, they would be F plus G, right? A and B and C, they would be what? They would be G. So where there is and, we are talking about both the activities simultaneously or together, right? Where there is or, we are talking about either of the activities. So I write A or B, how many people do A or B? It would be A plus B plus E plus G plus D plus F, right? So these are the people who do A or B. Similarly, you can construct A or C, right? And A or C or D, right? So this means either of the three activities, right? And finally, H are all those who do neither of the three activities, right? So in this way, we characterize all those people who do three activities. This is a very interesting question, or a very simple question, which would put things in perspective, which says 5% of a passenger who boarded Rajdhani do not like tea, ice cream or coffee, right? 10% like all, 20% like coffee, 25% like tea and coffee, 25% like ice cream and tea, 55% like coffee, 50% like tea, 50% like ice cream, right? So we have to find all these elements A, B, C, D and E, right? What we do is we create a universal set, 3 sets of ice cream, tea and coffees. So this may be one, then let's do another one. So this is another one, and finally the third one is this, right? Let's say this is tea, this is coffee, this is ice cream, right? So it says that 50% like tea, so this is 50. The overall number in this circle is 50, the overall number in this is 55, right? And the overall in ice cream is also 50. Further it says, so 5% like none, so 5% would be here. 10% like all, so 10% would be here. 20% like coffee and tea, so coffee and tea is 20. So 10 is already gone. What is left is 10, right? 25% like ice cream and coffee, so this one, this area. 10% already gone. What is left is 15 would be here. Then 25% like ice cream and tea, so this area, this and this. 10 is already gone. What is left is 15. Now we want what is the number in this one. So this would be 50 minus 10 minus 10 minus 15, which means 50 minus 35, which is again 15. Here again it would be 55 minus 20 minus 35, which is 20. And here again it would be 50 minus 40, so 15 plus 15 30 plus 10 40, would be 10. So how many people like only one beverage? It would be 15 plus 20 plus 10, which is how much? 30 plus 45% like only one beverage, right? So this is the difference, right? Now the question can be how many people like at least one beverage, right? So at least one beverage would be sum of all these numbers. So 50 plus 20 plus 10 plus 15 plus 15 plus 10 plus 10, right? So that would be 95. It has to be 95. So simple way out is 100 minus 5, right? Those people who like none are 5. So just subtract that and you would get this is equal to 95. So this is also a way of checking, right? If you add all of this, you have to get a 95 thing, right? So just check 15 threes are 45. So 10 threes are 30. 30 plus 20 50. 50 plus 45 is 95. So our answer is right. So and likewise, so how many people like only two of the three things? So it would be 10 plus 15 plus 15, which would be 30 40. So 40% people like only two of the three things. Then there can be question how many people like at least two things, which means they like two or more things. So this 10 has also to be added there, right? So this is what makes a set question interesting as well as difficult, right? So let's do one last question. This again is a UPSC question, an interesting one indeed, and I think this is one of the toughest questions which appeared in UPSC exam, right? Just try and do it. I'll give you 1.5 minutes, because if you don't understand the question you would not be able to solve it even if you are given 5 minutes, right? So just a quick 1.5 minutes for this question and then we'll wrap the session. So let's see what is in this question. In an examination there are three subjects A, B, C. A student has to pass in each of the subject to be declared as pass, right? 20% student fail in A, 22 in B and 16 in C. The total number of students in passing in whole of the examination lies between what, right? So this is very interesting. We have to find a range, right? So if this is the whole class, what we are given are sets of those who failed. So this is first set who failed in A. Let's say this is the second set who failed in B. And we are assuming that there are intersections. If there are no intersections, we call them mutually exclusive sets, right? And then so you don't need to require all those terminologies as such. So this is C, right? So it is A is given to be 22 or 20. A is given to be 20, B is 22 and C is 16. These are the number of students who fail, right? We have to find all the students who lie outside these three circles, right? So we have to find all the students who lie in this region. So this region overall has 100% students, right? So there are few who fail in these exams. Now here the good part is, or the interesting part is, we are not given what is the how many people are in this region or in this or in this or in this or in this. and likewise, right? We have to determine actually what could be the range of people who are here, right? Which means there has to be maximum and minimum, right? We have to allocate numbers to these regions in such a way so that we maximize this or minimize this. How do we minimize this? We minimize this if total number of students who fail in any one of the subjects increases, right? So if we do 16 here, 20 here and 22 here, right? Which means how much? 38 plus 20, 58% students fail, right? Because they fail in any of the subjects. So 58% student would not pass. They would not be called pass. So how many students would be called pass? 100 minus these 58, so which is 42. So minimum possible number would be 42. So what we are doing is to minimize the number who have passed. We are maximizing the number who have failed, right? And how do we do it? We keep these numbers as disjoint as possible, which means we try to keep them, we try to minimize the commonalities between these two numbers, right? Because if there are, let's say, 4 students common, so 4 would go from this and this as well, right? So 4 would go from both of this. So the unique number would be 4, right? And eventually the number of students would decrease. Now if we have to maximize the number of those students who pass, what should we do? We should minimize the number of students who fail. And how do we minimize them? Let's say these 16 students fail in all the 3 subjects, so this would come here, right? So out of these 22, 16 already are those who failed in C as well, right? So how many are left? There are 6 left. In this, how many are left? There are 4 left. So if we also include 4 students which are common in paper 1 and paper 2, which are common to fail in paper 1 and paper 2, how many are left? Only 2 are left. So in this way, only 22 students, we have constructed the problem in such a way that only 22 students are required to fulfill these conditions, which is 20 fail in paper 1, 22 fail in paper 2 and 16 fail in paper 3, right? We have to fulfill this condition, and this condition can be fulfilled in number of ways, right? So firstly, we maximized the number of students who failed. Now we have to minimize those numbers who failed, right? So how do we do that? We increase the commonalities, right? So 16 was the minimum, so we said that these 16 failed in 1 as well as in 2, right? Out of these 6, now what is left here? The 4 is left here. We say that these 4 fail in paper 1 and paper 2, and finally these 2 fail in only paper 2. So how many students fail either in paper 1 or paper 2 or paper 3? They would be 22. And then how many are pass? It would be 100 minus 22, which is equal to 78. So our range would be 42% to 78%, right? This becomes a slightly tricky question, but this is the most tricky thing which can happen in exam. If you practice these kind of questions, I'm sure you would be able to solve almost any exam in any question in any of the exams, right? I hope that you are clear with the basic theory of Venn diagrams and sets. You don't require high-fi formulas like A minus B, A complement B and all that stuff. I don't think that you would require in your CSAT exam or even in your bank PO exam. If you are clear with this, you would be able to solve 90% of the questions in Venn diagram or set kind of scenario, right? I hope that the basic part is clear and you would be able to solve almost all the question in your exam, right? So with this, we'll wind up our session. Thanks for watching this video, and I wish you all the best for your preparations.